Alrighty, so I'll post this video on my YouTube channel so you can take a look there. Okay, so the review questions that I'm picking are from the online Math 210 exam 3 review. Today we'll try to cover 13.1, 13.2, and 13.3, at least these three topics, okay? And Monday we'll cover the rest. So everybody has the document on hand and I'll be referring to those questions. So the first topic that I want you, these notes will be posted. Just look at the screen, make sure you understand the concepts, make sure you can remember the formulas for the exam, okay? Now this is Math 210, Exam 3 review. Exam is on November 20th. Okay, first section is 13.1. Before I start solving problems in this section, I need you to recall a few formulas which will be crucial for this course. Number one, what is the integral power rule? Just like derivatives, well, this is anti-derivatives, right? So it should be opposite. You add 1 to the power and divide by it, and there you go. Done. Easy peasy, right? The other formula you should be aware of is integral of 1 over x. Now that's a special guy. What is that integral? It's ln x plus c. If you see a square root, if you see an x at the bottom, you just move it up, make it a power, and be done with it. Two important formulas that you should know, which are shortcut, do not require a u substitution, is this one. If you have integral a to the power x, a is a number, okay? A is a number and x is a variable. This has a shortcut formula. We just copy that, divided by a. And plus c, because it's indefinite integral, there are no limits. And if I have same thing, if I have, well, that's it. This is the only thing we care about. And if I have just the regular e to the power, say negative 5x, let me do an example here. So how does this formula work? The ax, you just copy the e and you divide by whatever constant it's being multiplied with. In this case, it's being multiplied with a negative 5. So just please try to remember at least these formulas for 13.1, and rest will be problems. So I'm picking number B from question number 1 of your 13.1 section. Question 1, find the indefinite integral, expect a problem in exam. Number B. So the question is, I have 7 over x plus 1 over 3x to the power 7 dx. So that's the function. I'm trying to integrate it. You see I have 1 over x here. First thing you do is try to simplify. So how can I write this integral? I'm not applying any formulas from above. I'm just rewriting it. I'm separating the constants from the x terms. You see what I did? And I'm moving whatever x is in the bottom, I'm moving it up. And you see, this is a common mistake I saw in the first 2 exams. You leave the constant at the bottom. That is just a product, right? You only move the x up. So far, everybody with me? Everybody can do this in the exam? Okay, then we apply the formula. What is the integral for 1 over x? Just ln x, right? Good. What is the integral for x to the power negative 7? Well, you apply the power rule. You add 1. Now be careful with the signs here. I have a negative 7. So I get 7 ln x plus 1 over 3. I got x to the power negative 6 divided by negative 6, right? Now, if you want to leave it here, it's perfectly fine with me. But if you want to simplify more, you could. You could make the power positive by moving it to the bottom. So I would have negative 18 and I would have x to the power 6. This is also correct. If you had time, do that. Otherwise, leave it here. They're both correct. Okay? So this was the first question that is the most difficult of all of these. Good. Everybody can do this. Frank? Good. Now, let's do one more. Number F of the same question. Number F is, so now I have x squared plus 5x negative 2 divided by x dx. There is no quotient rule or product rule for integration. This is the sign of integration. So I have to simplify this. How do I simplify that? Anyone? Not a single person. Where is Moresh? Bruno? How do I simplify this? No. This is 13.1. This is simpler. Yes. Yeah, it's easier, right? Just split up the x. Don't forget that. It's easier than that. Don't do u substitution when you don't have to. I split up the x. Good. And now I simplify. So I can cancel out the power is just an x. This is just a constant. This is just negative 2 over x, right? Wait, let me add one more formula in the list. What do you think the formula I'm about to add here? Any guesses? Okay, I'm going to add the constant formula. If you have a constant inside the integral, what's the answer? You multiply it by an x, right? So I'm going to be using that constant formula here. Yeah, I will be posting all these notes. Okay, so now you have all the tools that are required to solve this problem. What is the formula for x? Just add a power, divide by it. What is the formula for a constant? It's just 5x. What is the formula for that? What is it? 2 times ln x. And don't forget the plus c here because, well, this is indefinite integral, right? Everybody okay with what I'm doing here? Any questions so far? So let's move on to a different type of problem, number 2. So you might get this question in exam, which is where you have to solve for the constant of integration. This is number 2 on your 13.1 section. So this is find f of x. Expect a multiple choice of something similar like this. So you're given the initial value and you're given the derivative in the question, which is 9 e to the power x plus 9. So that's the derivative that's given to you. You're given the initial value and they're asking you to find f of x. Question clear? We did solve plenty of examples like this during my lecture too. Okay, recall 2 things. That if I have antiderivative, that's a symbol, and I have derivative, together they cancel each other out and you get f of x. This is important, okay? If I have the derivative and the antiderivative together, they cancel, you get f of x. Now, I want to find f of x. That would just be the antiderivative of the f prime. And what is f prime? F prime is given to you in the question. And can you solve this integral? Apply the formulas. What is the formula for e to the power x? That's just e to the power x. What is the formula for 9? That's just plus c. Now we solve for the c. So this is f of x, right? Because they cancel. Can you solve for the c now? Use the given information. You're given f of 0 equals -1. So this means if I put x to be 0, my y value will be -1. Okay, who's going to tell me what is c? C is -10, right? And so we found the constant of integration. We replace it in the original formula and we get it. You have to pick the right answer from the multiple choice in exam. So make sure you do the math right. Now this is it. 13.1 is just basic integration with a little bit of application. Just remember two things. Integral, derivative together, they cancel. Now comes the difficult part. 13.2 is the u substitution. Now try to make it as simple as possible. This is 13.2 from your exam review. It's u substitution. Okay, so I'm gonna pick number. See, if you look at your notes on the exam review, they do tell you that you can use the shortcut formula, right? So that's what I want you to do in exam also. If you get a question like this in exam, use the formula that I've given you. What is the formula? Well, you leave the constant as it is. You divide by the coefficient that is multiplied, right? So I got 16 over -3 e to the power -3x plus c. So use the shortcut formula. We do not want to involve u substitution here. One more thing here. I should give you this shortcut formula also. If I have 1 over ax plus minus b, doesn't matter, dx. Okay, if you see something like this, a is a number, b is also a real number, and x is the variable, the shortcut formula is, this is just ln ax plus b divided by a and the constant. This is another shortcut formula that I would like you to remember to avoid u substitution. So we will not be doing any of these questions that can be used by shortcut. I want to solve part D here. Part D from your 13.2 notes on the Math 210 review. This is 4x e to the power x square -3 dx. Who's going to tell me what is the first step? Find the u. What is usually the u? The higher power, which is, so step 1 is find the u, which is the higher power or the exponent of e, x square minus 3. Differentiate. Du is 2x dx. I do have to balance the integral though. So I have x, I have dx, I have a 4. But I don't need to multiply it by 2, right? Look, I can do it like this. I have 2 times e to the power x square minus 3 times 2x dx, right? I break it up. And the whole point of this next step is this should match exactly to your du. So my 2x dx is matching du exactly, and then I proceed with the next step. So what is the new integral? Is 2e to the power u du. And here's a hint, the new integral should be easy peasy. Apply a formula, it should be solvable. Alrighty, what is that? What is that answer? Because the integral of e to the power u is just e to the power u. Okay, am I done here? How many agree that I'm done? I have to plug the u back in. Good job, smart choice. Don't leave it here. I have to do one more step. Instead of the u, I plug back my initial substitution. Right? Any questions? Anybody? You see how this flows? Okay, let's do one more. I've picked number F. Yes. So, because this is exactly matching with du, right? Du equals exactly that. So, I'm just replacing the 2x dx with du. It's just replacing everything that has to do with x with u. So, just like I had x plus y equals 7, and I gave you that y equals 3, you know what to do next. You replace your y with 3, right? It's the same concept. Because my du equals exactly that thing, I replace it with the du. Good? Question. Because I had a 4 here. Wait, which two are you talking about? Yeah, I had a 4 here, right? And I needed 2x dx. So I could break it up. X is here, right? So this is a product, right? I can move it back and forth. So I just break the 4 and I move the x with the dx. Yeah, it's still there. Yeah, so this whole thing is du replaced. Yes. Oh, that's the integral formula, right? Look at this one. What is the every time you apply the formula, you get rid of the dx. That is just like how you, when you apply the formula, you get rid of, that's just applying the formula part. Just like you, I didn't get rid of the du, I integrated. 2 eu du. What is the formula for integration of eu? Well, that's just that, right? But then you don't write it again, then you're done. That's just the formula. Just like if you are differentiating x cubed, what is that? It's just 3x squared, but then you don't write the prime, right? Because you applied the formula. Same thing, you're applying the formula. It doesn't matter. Yeah, because it's u here, right? Same thing. If I had a 2ex dx, it would still be 2ex. Good questions, but doesn't make sense to everybody? Can you do it in the exam? Let's do one more. So I'm picking number F here now. Next is number F on your list, which is 15x, and then I have square root negative x squared plus 7 dx. Okay, what is my u? Exactly. You take everything inside the square root. Don't take the square root. Square root will make du very complicated. We don't want that. We just want the thing inside the root. What is du? Negative 2x, right? Now I don't see a negative 2 in the question. Let's rewrite this integral first. When I say rewrite the integral, I mean move the x and the dx together. So look what I get. 15 negative x squared plus 7, and I'm moving the x dx together. So far good. I just rearranged my integral, and I have my u and I have my du, which has a negative 2 extra. How do I balance it? Next step is balance the integral, right? Look, I need a negative 2 here. On this part, I need to have a negative 2 multiplied. But whenever you multiply by something, you divide by it also. Okay, that's how you balance. So I'm gonna keep the 15, keep the square root as it is, but I multiply by a negative 2 here. Because I multiplied by a negative 2, I have to divide by it. Make sense? This is called balancing the integral. Don't forget the division part. Anybody, any questions? Now look, now the negative 2x dx is exactly du. So what do you get? I replace everything. So I have 15 square root u du. And that was the goal. We try to make it match exactly with the du. Good? And now this integral is easy for me. What is the answer here? What is the integral of square root of u? You add 1 to the power and you divide by it, right? It's just like derivatives. Turn the square root to a power, add 1 to it, divide by it, and you are done. So, but I'm not done here, right? You can simplify this over negative 2. I'm going to replace the u with the original substitution and add that power. What do you get? 3 over 2 divide by 3 over 2 plus c. You can leave it here. This is good enough. Okay, anybody, any questions? Yes. Yes. So because you see, when I find my du, I have a negative 2 extra, which is not in the question, right? Look at the question, and I don't see a negative 2 there. So what I do, when I balance it, I need to multiply it by negative 2. But when you're multiplying by something extra, you have to divide by it also. Because you don't want to change the question. To keep the question the same, whenever you multiply by something extra, which is not already there, divide by it within the integral. Yes. And then it matches. Yeah. Great point. We will always do that. You know why? Because this is the most complicated part of the question, right? So we keep the complicated part in the beginning and the constant remains, but the extra x goes to the dx. So you can move it, right? It's just multiplication. If I write 3 times 2 times 7, Or I write 7 times 2 times 3, same thing. I'm just moving them back and forth. But that's the goal. You keep the most difficult concept to the front and move everything to the dx. Good? Let's do one more, it will be more clear. I'm doing number H on 13.2 question. I'll post this video. You can watch this again. This is 3 ln x over x dx. What do you think should be my u? Now, this is a tricky question. Let me warn you. What is my u here? Exactly. Pick a nice u because u should be ln x. Why? Because when I differentiate it, I get. Remember this question. This is important. Okay. Every time you see ln x, that's your u. Because when you differentiate it, that's the remaining part will be. Now look how I break this question. This is similar to saying this. They're all being multiplied together, right? I have my u, I have my du. Du matches exactly to the question. So no need to balance anything here. Matches exactly to du. No need to multiply and divide. No need to balance. So I just simplify it. So I got 3, replace the ln x by u, replace the everything else by du, right? And what is the integral of u? Everybody can do this in exam? Okay, am I done here? Not yet. I have to replace the u by the original. That's it. 2 simple steps. Figure out your u in such a way that du is easy to find and it's already in the question. Let me do one more. All good here? Let's do one more example so that you have more practice because the next section is just application part. I'm doing number E on the list, which is x square plus 1 to the power 10 dx. This is number E on 13.2. Again, I need to figure out my u, which is always the higher power, but not the. So we are looking for the inside function. U is the inside function, if you notice. Here also, the u was the inside guy, right? Try to remember like that also. So e to the power that, u was the inside, the power of e, not the whole thing. So I figure out my u. What is du? Try to solve it on your own. Make sure you can do this in exam. Well, in this case, I got an extra. I got an extra 2, which is not in the question. So this question will require some balancing. So I move the x with the dx, right? So I balance the integral. Because in this case, the extra part, yes. Casey. Oh, it's 1, my bad. Good job, that was a test. You found the error. Good job. But I have to balance it, right? So what does that mean? I have to multiply by a 2 because the 2 is extra. So I need to divide by a half, right? Divide by a 2 also. This is the balancing part, which is the most difficult part for these type of problems. It should match du exactly. Once you have balanced the integral, then you just replace. So The inside function was u, that becomes power of 10. Everything extra becomes du. And now the integral is easy peasy. Add 1 to the power, divide by it, plus c. So I got, well, don't forget to replace it. You got 22. And this is how u substitution works. Anybody, any questions? Yes. What's the point of substituting? Well, if you try to integrate this without making a u substitution, can you come up with an answer? No, it's too difficult, right? So what we are trying to do here is make this integral, which is crazy, a little simpler by replacing the parts with u. So we're not making any changes to the problem. The problem remains the same, hence the balancing, right? But we make the question a little bit simpler by introducing another variable, which is u. Good? It's just to make the integral easy. Now, I'm coming to 13.3, which is the definite integral, the fundamental theorem of calculus, and the Riemann sum. I did give you an example, a homework exercise for Riemann sum also, right? Did you do that? Was it extra credit? Okay, I don't remember if it was a homework or extra credit, but 13.3 is all about definite integrals. Whatever you have learned so far, you will apply the same techniques. I'm doing let's do number F. The only difference is you have one extra step. You have limits. Everything else remains the same. You do the integration like you used to before. There is one extra step. So what is the integral of 2 over x? Just 2 ln x. The only difference, we will not do the plus c here, but we will apply the limits. How do I apply the limits? In exam, I highly recommend make 2 big brackets. In the first bracket, you replace the x with upper limit, which is e to the 5. In the second bracket, replace x with the lower limit. Okay, take out your calculator, see what's the answer. Yeah. Yeah.
Write the volumes like to the side, or when you made like the 200 checks yet to
What is the name we use?
like can you write the rule? Like what is the rule? Is that a rule? It's a rule, right?
It's the formula for 1 over x. That's what I wrote. It's all here. So what is the formula for 1 over x? All the important formulas will be on this file. Okay, good. Yes. Cancel out, right? Yes, that would be the smart move. Don't do any math. They cancel out. Even if you forget, what happened here? 4, right? Everybody got 4? Oh, that's it. How does question number, now this is going to be a multiple choice, okay? This is important. Sometimes your integral will have a variable limit. You have 2x minus 4 dx. It's given to you, it's 9. How do I solve a question like this? Well, I integrate as usual. What is the answer? You add 1 to the power, divide by it. If you have a constant, you multiply by x, and then you apply the lower and upper limits, the answer should equal 9. That's what it means. Everybody agree? Anybody who is not agreeing with this, raise hand. Okay. And now I have to simplify this. So the 2 cancel. So I got x squared minus 4x going from 2 up to b equals 9. Right? I just cancel the 2's. That's it. Now I need to make 2 big brackets. In the first bracket, I replace x with the upper limit, which is b. So I get b squared minus 4b. In the second bracket, I put the lower limit, which is 2 squared minus 4 times 2. Question? Yeah. Oh, I'm just replacing the x with the lower limit. Just remember this step, okay? Okay, who can solve for b here? Tell me an answer. So you get 4 minus 8. You get minus 4, which becomes plus 4 equals 9. So can you factor this quadratic? What is the b? You got 5? But we want a positive b, right? So 5 is the answer. Right? I'm assuming everybody knows how to. I've factored a quadratic with you before also. Okay, anybody, any questions with this? Yes. Last part here. Last question. That's the answer. Yeah. Yeah. Yes. That's your question? Okay, then you're good. Okay, let's quickly do the Riemann sum, then I can give you the quiz. Hold on, laptop is dying. Anybody else? Any other question? I will be posting this video and these notes. Okay, Riemann sum. How many of you remember how to find the Riemann sum? This is question number, I'm going to do question number 4. So you're given n equals 4 and you're given find the Riemann sum of this function. Very typical question will look like this in exam. You have to find the Riemann sum estimate of this integral given n equals 4. That's the number of rectangles you need to add. Number of areas for a multiple choice, that's what you need to do. Okay. First things first, how do I find my delta x? That's b minus a divided. Now you have to do a lot of memorization here, okay? What is my interval? Interval are the limits. So what is my delta x? So the width will be 0.25 for each rectangle, right? Everybody good with this? Delta x is the first step you do. Now, we begin by finding the value of the function at the starting point, the left point, f of a. What is a in this case? 2. Okay, find me f of 2. So plug in 2 in the function. I got 1 over 5. Agree? And then you keep going because you need 4 intervals. So you do 2 plus 0.25. This is iteration 1. Next. So I will add 0.25 to 2. That's going to be my next value to evaluate. Okay, keep your calculators out. Replace x with 2.25. What do you get? Okay, do it faster. I need to give you the quiz. The final answer. 1 over what? 5.5? Okay, 5.5 it is. The third, you add 0.25 to this one. What do you get? 2.5. Replace x with 2.5 in your function. What do you get? Well, because we have n equals 4, we have to do one more. Add 0.25 to the last guy. What do you get? Now this will require some, it's not going to be difficult like U substitution, but it requires memorization. You have to remember all this. 2 times 2.75. What's the answer? And you stop here. Because I had n equals 4, I stop. After 4 values. What is the Riemann sum? The left Riemann sum will be delta x that you calculated and add. So I begin adding from f of 2, keep going, f of 2.25. You don't have to write this in the exam. This is just for your understanding. I'm adding all these values. 2.75. Because I have 4 intervals, I should have 4 function values starting from the leftmost point. Delta x was 0.25. F of 2 was 1 over 5. F of 2.25 was 1 over 5.5. 2.5 was 1 over 6. This is 1 over 6.5. Okay, who's going to tell me the answer for this? I mean, you can use a calculator. Nobody? 0.20. Everybody getting the same answer? Okay, there you go. You got it. Good job. So this review, I've given you 3 problems from 13.1 to 13.3. You can work in groups, upload your solutions on Canvas. We'll catch up from here on Monday.